In the name of Allah, ladies and gentlemen, thank you for taking part in my presentation titled The Start of Combustion Prediction for Methane-Fueled HCCI Engines, Traditional vs Machine Learning Methods. This is prepared from a part of a large project titled Machine Learning in an Internal Combustion Engines is running by Drs. Namar, Jahanian, and Khotan. Homogeneous charge compression ignition engines is developed by the combination of two common combustion types, spark ignition and diesel combustion. Lean charge is compressed heavily until auto-ignition. The combustion chamber will be combusted suddenly with no flame propagation as the SI engine or fuel injection as diesel engine. So we have no direct control parameter for the ignition. The only way is controlling the start of combustion via initial conditions such as the equivalence ratio. Therefore, having a sufficient estimator is pretty necessary. Extended efforts were carried out to find such a model from three-dimensional CFD models to thermodynamical ones. In the next step, and for the real-time controlling approaches, semi-empirical models are introduced. Accuracy, feasibility, and the response time are considered as the key factors of their comparison. As an example, a modified Mach integral model uses a repetitive calculation from IVC to find its nonlinear integral value equal to 1. This means that the crank angle where the integral value is equal to 1, we have the combustion. Or in the SAM model, which is previously introduced by the authors, the start of combustion is calculated directly using a nonlinear correlation. Flourishing the machine learning techniques and applying them in the different fields of research, it seems we should answer this question. Is there any simpler correlation to have better response time, To answer that, we have no way expect testing. If we have the dataset of start of combustion due to the engine inlet parameter, the problem is a regression. So we test 11 models of linear and nonlinear regression models to find the answer. You can see the linear hypothesis means as the shout coloration, machine learning, find the best value of A to G. Used dataset is produced by the homemade engine simulator from 3 different methane-fueled HCCI engine. 1430 cases which are divided to the test and train set. Machine learning used train set cases to develop the model, and these models will be evaluated by the test set cases in the next step. First of all, the SAM performance is shown in the both of train and test dataset. Acceptable prediction range is less than 2 crank angle degree, and we see that the SAM almost predict 89% correctly from the test set. Seems good. We applied machine learning regression with different hypotheses, and the results were interesting. For example, using ordinary least squares model, we achieved pretty excellent performance with 98% accuracy. Although it should be noted that these models have a linear hypothesis, which means that the speed of calculation is obviously higher than the SAM. However, some other models may not correctly learn as a support vector regression or overfitted like decision tree model. Both of not learning or overfitting may cause not accurate prediction. And finally, and as the conclusion, we can assert that the answer of our main question was yes. We achieved at least 3 linear models with excellent performance. However, two other yellow shaded models have acceptable performance too. And we believe that this technique can be employed for any other correlation uh, using at ECU, electronic control unit of the engine. Great, thanks for your attention and staying safe, healthy, and happy.